Module 7, Lesson 2 deals with writing equations to represent relationships represented in tables. That's an awful lot of representing relationships involved there. The student objective is students will write an equation to represent relationships, and the pacing guide says this should be a 2-day lesson, so let's get started. At many county and state fairs, you must purchase tickets if you want to go on the rides. Different rides require a different number of tickets. The Ferris wheel, for example, might require 3 tickets, while the bumper cars might require 2 tickets. Before you buy tickets, it might be helpful to know which rides you plan to ride and how many tickets you are going to need. Each ride requires 3 tickets. If a ticket costs $1.50, how can you figure out how much it will cost to ride X rides? Well, this is all part of what we're going to be learning about in this lesson. Luciana earns $8 per hour walking dogs in her neighborhood. The table shows the relationship between the number of hours she walks and the total amount D in dollars she earns. To write an equation that relates the variables H and D, first you have to determine a rule that describes the relationship. You need to ask yourself, what's going to be the input? What's going to be the output? What is going to be the rule that connects the input to the output? Well, your input is going to be the number of hours that she walks a dog, and you can see that listed in the left-hand column. The output is the number of dollars she makes walking the dogs. And then the rule is going to be 1 times something, or 2 times something, or 3 times something. In other words, it's going to be the H right there times something is going to equal to the D for dollars. What is it going to be multiplying all those numbers by? It's going to be multiplying them by 8, because 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is going to be 32. So the rule H times 8, go ahead and highlight that there, accurately describes the relationship. Now notice that the ratio of each output to each input is going to be constant. If you simplify the fractions every time, you're going to get the same exact answer every time. They're going to be equivalent ratios. Now next, our textbook wants us to take and use the rule H times 8 to create an equation. Now remember, an equation is a mathematical expression, or 2 mathematical expressions that are connected with an equal sign. So my 2 mathematical expressions is going to be D right here for the number of dollars she earns is equal to, the other mathematical expression is going to be 8 times H for $8 times the number of hours that she worked. In example 1, the table shows the total cost in dollars, and cost is going to be listed as a variable C, of buying T souvenir t-shirts. So you can see they have the information here. Your input is going to be your number of t-shirts, T. Your output is going to be your total cost, C. And you've got to come up with a rule to connect the number of t-shirts to the total cost. So let's start working on that. First thing we're going to do is identify the variables. Now, I already pointed out that your input is going to be the number of t-shirts you purchase. The output is going to be the total cost of those t-shirts. From here, we can check that answer. That checks. Move on to the next level. Determine the rule. We can see that as we go down here, every single time you multiply the input by 9, you're going to get the output. So what's my rule going to be? My rule is going to be 9 times T is going to give me the output C. So right here, 9 times C, whatever the number of t-shirts are, multiply that times 9, you're going to get your total cost. Next, we're going to use that rule to write an equation relating the 2 variables T and C. So our equation is going to be what they show us right here. C, being the total cost, is equal to 9 times T. And you could also write that as 9 times T is equal to C. Either one of those is a perfectly good way of doing that. No matter what you're doing, though, you have to set it up to where your input, T, is multiplied by 9, and that is going to end up equaling your output. Now it's going to be your turn. Take a moment and pause the video and come up with a rule to connect P to T, where T is the number of teams and P is going to be the number of players. Now to do this, I have to ask myself, what do I multiply our T value by? For some reason my cursor is not working here. There we go. What do I multiply my T value by in order to get it to equal my P value? Well, 1 times what is going to be 12? And that's going to be 12. 2 times what is going to be 24? That's going to be 12 again. 3 times what is 36? That's going to be 12 again. 4 times 12 is going to be 48, and 5 times 12 is going to be 60. So my answer, T, that's going to be these values right here. So I have T times 12 is equal to my P value, which is right here. We could also rewrite that as 12T is equal to P, or the way the textbook wants it is P is equal to 12T. So now I'm going to jump back over here. P is equal to 12T. Check our answer, and the answer checks. It's as easy as that. Now the way we're blowing through this lesson, I really have my doubts about this being a 2-day lesson here. So next thing they want us to do is ask, how can you find a rule involving 2 steps for a relationship? And to do this, they're going to introduce a web sketch pad, and a 2-step, that's going to be a little bit more challenging to work with. So let's see what they want us to do. We're going to be using an input-output machine, and it's programmed to perform the 2 steps, which means there's going to be 2 different operations. For example, times and plus may be taking place. So they start off with 1, and when they put it in with the machine, they hit the run value, and what is it going to give us? Well, 7. So we know we probably ought to start making a chart of these so we have an idea of what's going on. So we're going to take and get some clean real estate here, and from here I'm going to take and say that 1 not equal to, but 1 became 7. That's not a very pretty 7. That's a better 7. Alright, let's do some more numbers with our machine. Next thing we're going to do is try 2 and run our machine again, and 2 becomes 10. So 2 goes to 10. And let's try another button here. 3. I said 3. Run the machine. 3 becomes 13. And let's do another one here. Let's do 4. So with 4, run our machine. 4 goes to 16. And with this, we get to start looking for a pattern as to what is connecting all these inputs and outputs together. Now your textbook suggested that we take and add 3, 4, and 5 for inputs. I added some other numbers for inputs, but theirs is good too. But no matter if you use their inputs or my inputs, you're going to come up with a table that looks kind of like this. And from here, we've got to take and figure out what we have to do to the input in 2 steps to get it to equal to the output. Probably going to be some multiplication or division. Probably going to be some addition or some subtraction here. It might just help if we took and showed what the first step was going to be. So I've got my machine here, same machine going back to 1. If we ran it, we still can get the same 7. But if we ask to show the first step, after the first step, the first number is going to be to multiply by 3. So 1 times 3 would be 3. What would you do from there to get to 7? You'd add 4. So how about if we would use a different number? If we'd use the 3 here, and we ran the machine again, well, guess what? It's still going to be 3 times 3, which is 9, and 9 plus what is 13? It's going to be 4 again. And with that, we have the information we need to actually solve this problem. Taking a little bit further with our machine, step 1 was to multiply by 3, and step 2, it was to add 4, just like we talked about. So with that in mind, what is our actual expression going to look like? Well, we're going to take our input value, and what do they call the input on these? Let me go back over here and look. The input is going to be, no, they didn't even tell you. We'll call them X and Y. We'll call my input X and my output Y. So it's going to be 3 times x plus 4 is equal to y for our output. So for example, 1 times 3 is 3, plus 4 is 7. 2 times 3 is 6, plus 4 is 10. 3 times 3 is 9, plus 4 is 13. 4 times 3 is 12, plus 4 is 16. So right here is going to be the equation that we come up with in order to solve this problem. Now I'm going to stop video 1 right here, come back in just a little bit to watch the rest of this lesson in part 2.